Hello, everybody. Welcome back. We are up to lesson 5. We're actually skipping lesson 4 and moving ahead to lesson 5. And what this lesson is about is something called the recursive definition or the recursive form of a sequence. You might remember in a previous lesson, I mentioned that one of the many ways that we can describe a sequence or represent a sequence is by producing new terms based on the previous terms. And what this recursive definition or recursive form does is basically put formal mathematical notation to it. And we're going to do that by using function notation. So you can see here that the recursive definition has two parts, and you have to have both parts to be considered correct. Okay, the first part is the starting term. I can tell you how to get a new term from the previous term, but if I don't tell you where to start, then you can't do it. So the starting term, which we're going to denote as f of 0, again using function notation, that's the first part of the recursive definition or recursive form. The second part, as you can see here, is going to depend on the operation, whether we're adding, whether we're subtracting, or whether we're multiplying by a number each time. And you can see this is how we represent f of n is going to be the mathematical representation or the mathematical symbol for the new term. And f of n minus 1 is going to be the mathematical representation of the previous term. So the way this reads is new term equals previous term plus a number, or minus a number, or times a number. I think it'll make more sense when I actually go through the examples. So let's go right to the examples on this lesson here. So for each sequence, we're going to determine whether it's geometric, arithmetic, or neither, and then we're going to write both parts of the recursive definition. Let's do the easy part first. Let's do the easy part first and do the geometric, arithmetic, or neither. Okay. So for number 1, you can see we're clearly adding 10 each time. So that's going to be an arithmetic sequence. Okay. Number 2, it looks like we're halving each time. We're dividing by 2. 80 divided by 2 is 40, divided by 2 is 20, so on and so forth. So we would describe this as multiplying by a half. So this is going to be a geometric sequence. Number 3 looks like it's going to be an arithmetic sequence. Why arithmetic? Because what are we subtracting? We're subtracting 7. 20 minus 7 is 13. 13 minus 7 is 6. 6 minus 7 is negative 1. So our pattern is to subtract 7 each time. Number 4 is going to be a geometric sequence again, because we're doubling. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So our pattern is to multiply by 2 each time. Number 5 is a little tricky, but this is also going to be a geometric sequence again, because we are actually halving each time. Half of 1 is 1/2. Half of 1/2 is 1/4. So we're dividing by 2 or multiplying by a half again each time. And then the last one is also going to be a geometric sequence because we're tripling each time, right? 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81, so on and so forth. So our pattern is to multiply by 3. So that now that we know what type of sequences each of these are, arithmetic, geometric, neither, and we know the pattern. Now we can go ahead and actually write the recursive definition or the recursive form of each of these sequences. So number one, as we said, is an arithmetic sequence. So to do that, let's go back to the lesson notes real quick. We're first going to write the starting term, f of 0 equals a number. So how is that going to work in this place? What is the starting term in this case? The starting term is 30. So our first part is going to be f of 0 equals 30. Our starting term is 30. And then for our next part, we're going to say, because our pattern is to add, we're going to use this one here. It's going to be f of n equals f of n minus 1 plus a number. So f of n equals f of n minus 1 plus a number. What is that number going to be in this case? Plus 10. So f of n minus 1 plus 10. So this right here that I'm boxing in is what we call the recursive definition or the recursive form of number 1. You have to have both parts to be considered correct. I cannot stress that enough. If you just write the second part, you are partially correct, but you are not completely correct. Again, I can't tell you how to get a new term from a previous term without first telling you where the starting term is. So for number 2, our starting term is going to be 80. So we're going to say f of 0 equals 80. And then f of n equals f of n minus 1. And what was our pattern? Our pattern was to multiply by a half. So f of n equals f of n minus 1 times 1/2. So that is your recursive for number 2. Number 3 was an arithmetic sequence. So again, our starting term is going to be 20. So we're going to say f of 0 equals 20. F of 0 equals 20. And then f of n equals f of n minus 1. And in this case, it's an arithmetic in which we're subtracting 7. So f of n minus 1 minus 7. And that is how we'll write it. Hopefully you're getting a hang of it. Let's quickly do the last 3. Number 4, our starting term is 1. So we'll say f of 0 equals 1. And then f of n equals f of n minus 1. And what was the pattern here? To multiply by 2. So times 2. Okay. Number 5, we have f of 0, again, equals 1. And then it's going to be f of n equals f of n minus 1. And our pattern is to multiply by half. So times 1/2. All right, and lastly, number 6, our starting term is 3. So f of 0 equals 3. And then f of n is going to be equal to f of n minus 1 times 3. Why times 3? Because our pattern was to triple or multiply by 3 each time. So you can see once you get the hang of it, it's not too bad. But again, the really important part is that you write both parts. You write your a starting term, and then you write how to get each new term from the previous term. That is, again, what we call the recursive definition or the recursive form.